Hello and welcome to the 30th video lecture of Quantitative Techniques Semester 3 Module number 2. In today's video lecture we are going to start with where we had left off in the 29th video lecture, that is simple problems on probability. In our previous problems we had started about problems with cars, and that is where we will start today. So let us begin. So our problem number 10 goes like this. A bag contains 3 red balls, 2 green balls and 5 white balls. Okay, a bag contains 3 red balls, 2 green balls and 5 white balls. So there are a total of 10 balls in a bag. 3 of them are red, 2 are green and 5 are white in color. So one ball is picked or selected at random. What is the probability that the ball that is selected is a red ball, a white ball, and the C1 says a green ball or a red ball. So let us solve this step by step. So total number of balls, we know that there are 10 balls, out of which we are selecting one ball. Remember, this selection of one ball is important because when it becomes more than two balls, there are more than one ball, that is two balls, three balls, the type of problem or the way of solution is little different, way of counting we can say is little different. Whenever it comes, only one card is drawn, one ball is selected, one coin is tossed, the problem is quite easy. We do not need to go for much calculations. But when the number of balls being selected at a time increases, it becomes little complicated. We will take those problems also later, but for the time being it is a simple problem where only one ball is picked. So the problem solution goes like this. Experiment. What is the experiment that we are conducting? The experiment that we are conducting is picking or selection of a ball, that is one ball. So n of s is equals to 10. No need to write this. This is for your explanation only. There are 3 red balls, 2 green balls, 5 white balls. Total we have 10 balls. So n of s is equals to 10. Out of these 10, that is your sample space actually is like this: R R R G G W W W W W. So 5 white balls, 2 green balls and 5 white balls, 2 green balls and 3 red balls. This is your sample space. So total directly you can write here, if you want, n of s is equals to 10, because there are 10 balls out of which you are going to select any one ball. Okay, the first event says that it is a red ball. So how many red balls you have in that? The answer is n of a is equals to 3 red balls you have. Just if I write the sample space once again for your reference: red, 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 green, green, white, 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 white. So total items in the sample space were 10. So n of s was equal to 10. Now the event a says that it is a red ball. So n of a will be equal to 3 because we have 3 red balls. Okay, so 3 red balls, so n of a equal to 3 we have. So n of a equal to n of s, p of a is equals to n of a upon n of s. So n of a is nothing but 3 divided by 10, right? So which is equals to 0.3. So now let us take the second event, a white ball. Now suppose if the selected item is a white ball, so how many white balls were there? We have 5 white balls. Okay, how many white balls are there? We have 5 white balls. Now probability of b is equals to n of b upon n of s, which is equals to 5 upon 10, which is equals to 0.5. So this was also quite straightforward, and this because it was similar to the previous subsection. Now C, event C will take green balls. How many green balls do you a green ball and a red ball. Suppose you are picking up, putting your hand and in the bag and picking up two balls. One ball is green and the other ball is red in color. Now this is the case. So total how many items will be there in your set C? Totally two green balls and three red balls. So totally five balls are there. So total five balls will be five available for selection. So probability of C is equals to n of C or upon n of S, which is equals to n of C is equal to 5, 5 upon 10, which is equals to 0.5. So this is about the selection of balls. Okay, so these type of balls problems have so far not been asked in your examination, but this may come because these are quite easier. The next problem that we are taking are where two balls are selected at a time. I would say that those people who are looking to score 80 out of 80 or somewhere very high marks in quantitative techniques only concentrate on the next problem. Those people who are looking to pass or somewhere close to 60 marks or something, 55-60 marks out of 80, they can leave the next problem because this is little confusing. You should know your primary and high school mathematics, that is permutations and combinations for this. So let us begin 11th problem. You can look and copy this in your fair book, but those people who are looking to score only need to study this problem. Now the problem is like this. The same problem I've taken. A bag contains 3 red balls, 2 green balls, 5 white balls, total 10 balls. So two balls are selected. Instead of one, we are selecting 2 balls are selected at a time at random. What is the probability that both the balls are green, one is red and the other is white, one is green and the other is red? So two balls are taken at a time. Whenever 2 3 balls are taken, the counting technique changes. Experiment remains the same. Only thing is two balls are selected or drawn from the bag. Okay, out of the bag. Now n of s is equals to, how can you draw two balls out of 10? See, you will draw two balls out of 10 balls. So number of ways of selecting two balls out of 10 balls is given by something known as NC2. I hope you know this. NC2, whenever you have n balls, n items, and you are gonna select uh, r items at a time, then it is given as number of possible ways of doing that is NCR. Total number of items available for selection and number of items you are taking at a time. Fine. So this is known as combination technique. Now the total number of items available for selection were 10, and how many items you are taking at a time? 2 at a time. So 10C2 it becomes. So how is this calculated? So 10C2 is written as, you start with this number, whatever is there at the top, multiply it by one number less. So suppose if you start with 10, okay, one number less 9, now one number less 8, one number less 7. You have to go on. For how many digits should be there? These many digits should be there. In this case we have 2 at the bottom. Okay, so that means only two numbers you have to take. 10 into 9. Suppose if it was 3 instead of 2, we had 3, then you could have gone for 10 into 9 into 8. Suppose if it was 4 at the bottom, the 10 into 9 into 8 into 7 would have come, and so on. Fine. So now you know that the numerator is 10 into 9 divided by, what is the denominator? Denominator will start with the bottom number. See, numerator started with the top number, denominator will start with the bottom number is 2, and it will go 2 into 1. Why 2 into 1 is, whatever number it is, you have to multiply by one number less, up till 1. Suppose if the bottom number was, say, if the bottom number was 5, then you could, your denominator could have been 5 into 4 into 3 into 2 into 1. If the bottom number was 7, then it would be 7 into 6 into 5 into 4 into 3 into 2 into 1. If the bottom number was 5, sorry, 3, then it would have been 3 into 2 into 1. So whatever bottom number is there, in this case the bottom number is 2, so it will start with 2 and it will go up till 1, 2 into 1. So this is how you have to do the denominator. I hope you know the now the calculation about combination. If you have any difficulty, you can call me. I'll send you a video on how to find out permutations and combinations. For this case you have to use combination only. Okay, so 10 into 9 upon 2 into 1, which is equals to, if you calculate using your calculators, it comes up to 45. So n of s is equals to 45. Now let us go to event A. We'll take only event A for today and we'll stop. Okay, event A. What is event A? Event A, both the balls are green in color. Okay, both the balls are green in color. That means, see, both the balls can be red in color, both the balls can be green in color, both the balls can be white in color. One ball can be red, one ball can be white, one instance. The other instance is one red, other green. The other instance is one green, other red, and there are a lot of other combinations possible. So what happens is, see here, we have, how many red balls are possible? See, they are saying that both the balls here, both the balls are green in color. So if both the balls are green in color, that means how many white balls are you drawing, how many green balls are you drawing, how many red balls are you drawing? 3 red balls are there. So out of 3 available for selection, how many red balls are you drawing? 0, because both the balls are green. How many green balls are there? 2. So 2. How many are you drawing at a time? 2. How many white balls are there? 5. How many are you drawing? 0. That means both the balls are green in color. 0 white balls, 0 red balls. Fine. Okay. Now, whenever, see here, what is the meaning of this is 3 red multiplication means and, sorry, what is the meaning of this is 0 red balls and at the same time 2 green balls and at the same time 0 white balls. Okay, that is the meaning of this. So if you multiply this, because and is there, you have to multiply this. If you multiply and solve this, you will get 3C0. I had given you some standard values during the formula in the first class of this second module. You can go through those formulas if you have written this in your fair book. NC0 is always equal to 1. So 1, I cannot, can I shift it here? No, shifting is not possible, so I have to cancel this. Just look at this. In 3C0 is 1 multiplied by 2C2. Start with 2, go up till 1, and only 2 digits you should have. So 2 into 1 divided by, start with 2 in the denominator because the bottom number is 2 here. So you have 2 into 1 multiplied by 5C0 is always equal to 1. So answer is equal to 1. So both the numbers are green in color. Answer is 1. Somehow I have forgotten to write it. Okay, 1. So n of a is 1. Now I'll just write it on, overwrite this, just see. So probability of a is equals to n of a upon n of s, which is equals to, what is n of a? I've got 1. What is n of s? 45. Okay, n of a is 1, n of s is 45, so it is 1 upon 45. So this is your answer, 1 upon 45. You can use the calculator and write it in decimal format also. Okay, so this is will if you have any difficulty about any of these problems, you can contact me. I shall complete the 11th problem in the next video lecture. Okay.